On a quiet night, the universe seems calm, its sky scattered with the soft glow of distant stars. Yet this serenity is an illusion. Without warning, the darkness can be torn apart by a sudden burst of unimaginable energy, brighter than 1 billion suns and powerful enough to echo across galaxies. Such an event is not the work of an ordinary star, but the calling card of one of nature's rarest and most dangerous creations, the Magnetar. A magnetar is a kind of neutron star, the compact corpse left behind when a massive star dies in a supernova explosion. Although only about the size of a city, it packs more mass than the sun, crushed into matter so dense that a teaspoon of it would outweigh a mountain. But density is only part of its terrifying story. What makes the magnetar truly monstrous is its magnetic field, an invisible force so strong it dwarfs anything else known in the universe, trillions of times greater than Earth's own. If a magnetar somehow appeared within half the distance to the moon, its magnetic pull could strip data from every hard drive and credit card on our planet in an instant. Scientists struggle to comprehend the sheer extremes these stars represent. They question what drives such violent forces, what causes the starquakes and eruptions that release torrents of radiation, and why magnetars are so rare compared to other stellar remnants. They are cosmic riddles, flickering in the night with both beauty and menace. This journey will take us into the world of these hidden monsters, exploring their origins, their devastating power, and the questions that still haunt astronomers. In the universe's darkest corners, magnetars stand as reminders of nature's ultimate strength and mystery. Every star, no matter how majestic, carries within it the seed of its own destruction. The most massive stars live fast and die violently, burning their fuel with such ferocity that they exhaust themselves in only a few million years. When they finally collapse, they do so in an explosion so powerful it can briefly outshine an entire galaxy. This is the supernova, the last act of a giant star. What remains after this cosmic detonation depends on the mass of the star's core. Sometimes a black hole forms, swallowing everything into its abyss. But in other cases, the collapse halts just before that fate, creating an object of staggering density, a neutron star. To imagine a neutron star is to confront the unimaginable. A sphere no wider than a city, yet containing more mass than our sun. Its matter is so compressed that protons and electrons have fused into neutrons, forming a sea of subatomic particles crushed into a rigid crust. As astrophysicist Jocelyn Bell Burnell once remarked, a teaspoon of neutron star material weighs about a mountain. The very laws of physics bend under these conditions, making neutron stars some of the most exotic objects ever discovered. And among these already extreme remnants lies an even stranger subclass, the magnetar. Born from the same fiery depths, magnetars are forged when a collapsing core retains not just its density, but also a magnetic dynamo of unimaginable strength. Scientists believe that rapid rotation during the collapse can amplify magnetic fields to levels trillions of times stronger than Earth's, locking the newborn star in a magnetic straitjacket that defines its destiny. The first hints of their existence came not from telescopes pointed at the night sky, but from sudden blinding flashes of gamma rays detected by satellites in the late 20th century. At first, these bursts were thought to be nuclear explosions on Earth, or strange signals from spacecraft. Only later did astronomers realize they were witnessing eruptions from deep space, starquakes cracking the crust of magnetars and releasing titanic bursts of energy. Today, fewer than 30 confirmed magnetars are known in our Milky Way. They are rare beacons, flickering unpredictably in the darkness, reminding us of how little we truly know. Each one is a cosmic laboratory, a window into extremes no experiment on Earth could ever replicate. They stand as rare survivors of stellar death, both terrifying and invaluable to science, and their scarcity makes every discovery precious. Magnetars are among the strangest monsters the universe has ever created. Their most defining feature is their magnetic field, so powerful that it reshapes matter itself. Earth's magnetic field, the invisible shield that protects us from solar radiation, seems almost non-existent in comparison. A magnetar's magnetic grip is trillions of times stronger, a force capable of distorting atomic structures. If one of these stars were somehow transported within a few 100,000 kilometers of our planet, it would tear apart molecular bonds, stripping electrons from atoms and leaving Earth unrecognizable. No known laboratory can reproduce such conditions. These are magnetic monsters beyond imagination, but magnetars are not silent. Their magnetic fury often builds up beneath the crust until it becomes unbearable. Then, like the shifting of tectonic plates on Earth, the crust cracks, producing what scientists call a starquake. In that single moment, enormous amounts of energy are unleashed as radiation, lighting up space with bursts so bright they can be detected across galaxies. One such event in 2004 released more energy in a fraction of a second than the Sun emits in 100,000 years. As astronomer Robert Duncan explained, it's like the universe itself is shouting at us. If only for an instant, these bursts are unpredictable, violent, and awe-inspiring. Cosmic firestorms that remind us how fragile our own world is under the universe's gaze. Inside a magnetar lies a structure that challenges our imagination. The surface is a solid crust of neutrons, harder than steel yet constantly stressed by the twisting magnetic field. Beneath it, a dense ocean of superfluid neutrons flows, behaving more like a quantum liquid than ordinary matter. At the core lies a mystery, perhaps quarks and exotic particles compressed into a state we can scarcely describe. Every layer of this star is pushed beyond the limits of known physics, making magnetars not just stars, but natural laboratories for the most extreme conditions in the cosmos. When they erupt, the scale of their energy output defies comprehension. A single flare can outshine every other star in our galaxy, if only for a heartbeat. To put it in perspective, the energy released in that instant could power human civilization for millions of years. These flares sweep across the galaxy, carrying X-rays and gamma rays that batter anything in their path. Even at safe distances, they can trigger detectors aboard satellites, causing instruments to spike with alarms. To witness such power, even indirectly, is to glimpse the raw might of the cosmos. Detecting magnetars is a challenge, yet it is also how they first revealed themselves. Telescopes designed to catch high-energy radiation, such as NASA's Chandra X-ray Observatory and the Fermi Gamma Ray Space Telescope, scour the heavens for sudden flashes. Radio telescopes, too, have found connections between magnetars and mysterious FastRadioBursts, millisecond pulses of energy that have puzzled astronomers for years. By combining data across the electromagnetic spectrum, scientists slowly piece together the life stories of these rare objects. Still, many of their secrets remain hidden behind their violent nature. The question of how such enormous magnetic fields are forged has driven decades of research. One theory suggests that when a massive star collapses into a neutron star, it can be born spinning hundreds of times per second. This rapid rotation acts like a cosmic dynamo, amplifying the magnetic field to terrifying levels. Another theory hints that turbulence during the collapse could lock in magnetic chaos, freezing the newborn star in a magnetic prison. Whatever the case, magnetars emerge as the most magnetic objects ever known, their fields decaying slowly but violently over time. Yet magnetars do not last forever. Their lives, though dazzling, are short compared to other stars. As their magnetic fields decay, their activity quiets, and they slowly fade into more ordinary neutron stars. In cosmic terms, they live fast and burn out quickly, an intense but fleeting phase in the life cycle of stellar corpses. Each magnetar we observe is a rare snapshot of this brief window, a glimpse into a process that may shape the very fabric of galaxies. Perhaps the most astonishing truth is that these unimaginable extremes can be contained within something so small. A magnetar may be only 20 kilometers across, yet its density is staggering. A single teaspoon of its matter would weigh as much as a mountain. This metaphor, repeated in classrooms and documentaries, barely scratches the surface of what that density means. It is the collapse of matter itself into its most fundamental form, a reminder that in the universe, size does not equal power. These tiny stars, no bigger than a city, wield forces that dwarf entire worlds. In the end, magnetars are paradoxes, dead stars that seem more alive than ever, frozen corpses that pulse with energy, compact objects that hold within them the power to shape galaxies. They are a reminder that the universe is not simply vast, but also intensely concentrated, compressing unimaginable power into the smallest of spaces. And though we have begun to peel back the layers of their mystery, much remains unseen, hidden behind walls of radiation and distance. Magnetars are not just distant curiosities. Their influence can stretch across space to touch worlds far from their origin. If one were to erupt close enough to Earth, its magnetic fury could disrupt satellites, scramble communications, and even induce currents in power grids, demonstrating that cosmic events can ripple through technology-dependent societies. We are tiny spectators to events that dwarf our understanding, says Dr. Elena Ramirez, an astrophysicist studying high-energy phenomena. Though no magnetar poses an immediate threat, their potential reminds us of the delicate balance of life on a small planet in a vast universe. Yet the true importance of magnetars extends beyond their immediate danger. They are now considered prime suspects behind some of the universe's most baffling phenomena. FastRadioBursts, millisecond-long flashes of energy detected from distant galaxies. Some of these bursts appear to originate from magnetars, linking these exotic stars to events that puzzle scientists across the globe. Gamma-ray-bursts, too, may be partially driven by magnetar activity, connecting these stars to explosions that can outshine entire galaxies in moments. As Dr. Li Wei observes, magnetars may hold the key to decoding signals we have only just begun to understand. These stars also offer a glimpse into matter under extreme conditions. Their cores compress particles into states that cannot be recreated on Earth, allowing astrophysicists to test theories of nuclear physics and quantum mechanics in ways otherwise impossible. The pressures, densities, and magnetic forces inside magnetars push matter to its breaking point, revealing new insights into the behavior of the universe's building blocks. Each eruption and flare is a natural experiment, a cosmic stress test of physics itself. Beyond physics, magnetars serve as natural laboratories for understanding the life cycles of stars and the evolution of galaxies. Their violent deaths and sporadic activity help astronomers map how matter circulates through space, contributing to the chemical enrichment of the cosmos. They also provide a potential window into the formation of black holes. Some magnetars may collapse into black holes, while others influence the emission of gravitational waves during cosmic collisions. These connections make magnetars more than scientific oddities. They are pivotal players in the cosmic web. Studying magnetars also shapes our understanding of the universe's history. By observing their locations, activity, and lifetimes, scientists gain clues about stellar populations, the dynamics of supernova remnants, and the processes that sculpt galaxies over billions of years. Each magnetar is a storyteller, offering fragments of history embedded in radiation and magnetic fields. Ultimately, magnetars are both terrifying and invaluable. They remind us of our fragility, the reach of cosmic forces, and the power of nature to operate on scales we can scarcely imagine. At the same time, they serve as living laboratories, testing the boundaries of physics and giving humanity the rare opportunity to study extreme matter, energy, and gravity, all from the safety of millions of light years away. They are both cosmic threats and cosmic teachers, shaping our understanding of the universe in ways that will resonate for generations. Magnetars hold a reign unlike any other in the universe. These compact magnetic titans, born from the deaths of massive stars, are the most extreme and dangerous stellar objects known. Their existence reminds us that the cosmos is not only vast, but also capable of concentrating unfathomable power into the smallest corners. Even from millions of light years away, their eruptions and magnetic storms shape the very fabric of galaxies, proving that size is no measure of influence. Yet for all we have learned, many questions remain unanswered. Why do only some neutron stars become magnetars? How exactly do their magnetic fields reach such incredible strengths? And why do their violent flares appear so sporadic? Even their numbers are a mystery. Fewer than a few dozen are confirmed in our galaxy, leaving scientists to wonder how many remain hidden, quietly waiting to reveal themselves. Dr. Anika Shah, an astrophysicist studying extreme stars, reflects, Each magnetar we find is a piece of a puzzle that the universe has been assembling for billions of years. The future, however, is bright for discovery. Next-generation X-ray and gamma-ray observatories will scan the sky with unprecedented precision, seeking the faintest bursts of energy and uncovering magnetars that have evaded detection. Advanced radio telescopes may finally decode the connection between these stars and enigmatic FastRadioBursts, bridging gaps in our understanding of high-energy astrophysics. With each new mission, we edge closer to answering the questions that have haunted astronomers since their discovery. In the silent darkness of space, magnetars stand as enduring symbols of power and mystery. They are both warnings and teachers, cosmic laboratories of extremes, and reminders that the universe holds secrets far beyond human comprehension. As we look to the stars, the story of magnetars challenges us to imagine, to explore, and to marvel at the raw, untamed forces shaping the cosmos. In their silent dominion, they remain a testament to the ultimate power and wonder of the universe.